first started seeing spectacular images of the cosmos that were captured by the powerful James Webb Telescope.
There was estimated that there were maybe a planet around every 100 stars.
Welcome to our channel. Today we're diving into the incredible discoveries made by the James Webb Space Telescope since its launch. Bigger, badder, and more powerful than Hubble, the JWST is peering deep into the cosmos, revealing secrets of the universe that have been hidden for billions of years. It's like getting a brand new pair of prescription glasses after a lifetime of blurry vision. We're talking about groundbreaking observations of the most distant galaxies, the birth of stars, the atmospheres of alien planets. The list goes on, so buckle up, space cadets, as we explore the mind-blowing discoveries of the James Webb Space Telescope. Remember that feeling of anticipation, waiting for the very first images from Webb? That moment was the culmination of decades of tireless work by thousands of scientists and engineers. Those first images, as awe-inspiring as they were, served as a confirmation, a resounding, "We made it," to the world. They demonstrated that this incredible observatory, stationed a million miles away, was working perfectly. Think about that for a second. A telescope, more intricate than any ever built, unfolded itself in space and focused light from the most distant objects in the universe onto a detector the size of a postage stamp. And what did that light reveal? Galaxies, billions of light years away, some formed just a few 100 million years after the Big Bang. It was a glimpse into the universe's infancy, a time never before seen with such clarity. That's the power of the James Webb Space Telescope. For centuries, humans have looked up at the stars and wondered, are we alone? The James Webb Space Telescope might just hold the key to answering this age-old question. Webb studies exoplanets, planets orbiting other stars, by analyzing the light that filters through their atmospheres. Think of it like this. Imagine holding a prism up to sunlight. You see a rainbow of colors, right? Well, each of those colors represents a different wavelength of light. When starlight passes through an exoplanet's atmosphere, certain wavelengths get absorbed by the gases present. By analyzing the remaining light, Webb can tell us what those gases are. Water vapor, methane, carbon dioxide. These are all molecules that could be potential biosignatures, hints that life might exist on these distant worlds. The search for life beyond Earth is one of humanity's greatest endeavors, and thanks to the James Webb Space Telescope, we're one step closer to answering that profound question. Stars, those twinkling diamonds scattered across the night sky, they don't just appear out of thin air, do they? No, they're born in vast, swirling clouds of gas and dust called nebulae. These cosmic nurseries are where gravity gathers and compresses these materials, heating them up until nuclear fusion ignites, and boom, a star is born. Before Webb, peering into these stellar nurseries was like trying to see through a thick fog. The dust obscured our view, but Webb sees in infrared light which cuts through the dust, allowing us to witness star formation in unprecedented detail. Imagine seeing a star in its infancy, still swaddled in its cocoon of gas and dust. Webb is capturing these incredible moments, revealing the intricate processes that govern star birth. These observations aren't just visually stunning, they're revolutionizing our understanding of how stars are born, how they evolve, and how they influence the formation of planets and galaxies. Galaxies, these vast islands of stars, gas, and dust scattered throughout the cosmos, they're not just random collections of celestial objects. They're dynamic structures constantly evolving, colliding, and merging over billions of years. Understanding how galaxies form and evolve is crucial to understanding the universe itself, and this is where the James Webb Space Telescope truly shines. With its unparalleled sensitivity and resolution, Webb is peering back in time, observing galaxies as they were billions of years ago. We're seeing the earliest galaxies, those that formed shortly after the Big Bang, still small and clumpy in the process of building themselves up. Webb's observations are providing crucial data that's helping astronomers piece together the complex puzzle of galaxy formation and evolution. It's like finding a missing piece of a jigsaw puzzle that suddenly makes the whole picture clear. Black holes, these enigmatic objects, regions of space-time where gravity is so strong that nothing, not even light, can escape. They're like cosmic vacuum cleaners, devouring anything that gets too close. Now you might be thinking, wait a minute, if black holes are black, how can we even see them? Well, we can't see the black hole itself, but we can see the effects it has on its surroundings. As matter falls into a black hole, it forms a swirling disk of superheated gas, called an accretion disk. This disk emits intense radiation, including X-rays and gamma rays, which Webb can detect. Webb is also helping us study the jets of material that blast out from the poles of supermassive black holes, those behemoths that lurk at the centers of galaxies. By studying black holes and their environments, Webb is providing us with a glimpse into some of the most extreme and enigmatic phenomena in the universe. Let's talk about one of the biggest mysteries in astrophysics: dark matter. This elusive substance makes up about 85% of the matter in the universe. Yet we can't see it or interact with it directly. We know dark matter exists because of its gravitational effects on visible matter. Galaxies rotate faster than they should if they were only made up of the matter we can see. It's like there's an invisible hand holding everything together. While Webb can't see dark matter directly, it can study its effects on the distribution and motion of galaxies. By mapping the distribution of dark matter, Webb can help us understand its properties and how it influences the formation and evolution of structures in the universe. It's like trying to map out a wind tunnel by observing the movement of smoke. Webb is helping us see the wind of dark matter. Remember those breathtaking images released by NASA, the ones that looked like towering mountains and valleys bathed in starlight? Those, my friends, are the cosmic cliffs, and they're not just a pretty picture. These cliffs are actually the edge of a giant gas cavity within the Carina Nebula, a massive star-forming region located about 7,500 light-years away from Earth. The peaks you see are towering pillars of gas and dust, sculpted by the intense radiation and stellar winds from nearby massive stars. Webb's infrared vision allows us to peer through the dust and gas, revealing the hidden nurseries where new stars are being born. It's like seeing a baby's first breath. These stars are just igniting, their light pushing back against the surrounding material. These images aren't just visually stunning, they're providing us with valuable insights into the processes of star formation and how stars influence their surroundings. It's a cosmic ballet of creation, and we have a front row seat. The James Webb Space Telescope is a time machine, allowing us to peer back billions of years to the early universe, a time when the first stars and galaxies were forming. Remember, the light from these distant objects has been traveling for billions of years to reach us, so when we look at them, we're seeing them as they were in the distant past. Webb is specifically designed to detect the faint infrared light from these early galaxies, light that has been stretched or redshifted as the universe has expanded. By studying these early galaxies, we can learn about the conditions in the early universe, how galaxies formed and evolved over time, and even test our understanding of the Big Bang theory. It's like finding a long-lost diary from your ancestors, filled with clues about your family history. Webb is providing us with a glimpse into the universe's baby pictures, revealing its earliest chapters. Stars, like us, have a life cycle. They're born, they live, and they die. And some stars, the really massive ones, go out with a bang, a supernova. These cosmic explosions are some of the most powerful events in the universe, outshining entire galaxies for a brief time. They're also responsible for creating many of the elements that make up you and me. Webb can study supernovae in unprecedented detail, analyzing the chemical composition of the expanding debris cloud. This helps us understand the processes that occur during these explosive events and how they contribute to the enrichment of the interstellar medium. Imagine witnessing the death throes of a star, the shock waves rippling through space, the creation of heavy elements scattered into the cosmos. It's a reminder of the constant cycle of creation and destruction that shapes our universe. The space between stars isn't empty, it's filled with a diffuse mixture of gas and dust called the interstellar medium, or ISM for short. This ISM might seem insignificant, but it's actually the birthplace of new stars and planets. It's like the cosmic garden where the seeds of future generations of stars are sown. Webb, with its infrared vision, can peer through the dust and gas of the ISM, revealing its hidden secrets. We're talking about mapping the distribution of different elements, studying the formation of molecules in space, and even detecting the faint glow of dust grains heated by starlight. Understanding the ISM is crucial to understanding the big picture of how stars and planets form and evolve. Webb is giving us that deeper understanding of the cosmic environment. And there you have it, folks, a glimpse into the mind-blowing discoveries of the James Webb Space Telescope. We've journeyed from the birth of stars and stellar nurseries to the explosive deaths of supernovae, from the formation of galaxies to the mysterious realm of black holes. Who knows what incredible discoveries await us in the years to come? Thanks for watching. If you enjoyed this video, make sure to like, subscribe, and hit the bell icon for more fascinating content about space and astronomy. Keep looking up and never stop exploring the universe around us.